So, welcome to today's lecture on cloud classification, and hopefully we're gonna finish today, and then we're gonna little bit go forward about the classification of the precipitation. So, in the last class, we have discussed most of the part of the cloud classification, and today we are going to discuss about the cloud classification in the lower levels. Sorry. So in low level clouds we have the clouds which is below 2 kilometer and normally consisted of liquid water droplets, because as its height is not too much extended from the ground, so the temperature is not very cool in here. So do we expect most of the cases the water droplets which is coming, it should be water rather than the ice crystals. And sometimes some of the clouds which can also be in a form that it is a watery vapor or maybe in foggy conditions, so that it doesn't give us much of the rainfall, or maybe sometimes it can give us the drizzle, that means very minute rainfall. So how we can differentiate it? We can differentiate it five subclasses from them. First of all, nimbostratus. It is a stratus type of clouds, and this type of clouds can be characterized as this can cover your whole of the sky. You can see the little gray or gray, dark and gray, whitish or bluish sky, and the clouds are looking like that is looking like some ragged shaped. Ragged means the turning up. That means if your cloth or paper has been torn off or cut off, you can expected this type of structure. And you cannot also see the sunshine from this type of clouds. This has been developed by one after another, layer after layer, and you can also expect a moderate to slight to moderate type of rainfall from nimbostratus. So this is the status of the nimbostratus, and nimbostratus sometimes it can be confused with altostratus cloud. Altostratus is a mid-type, mid-level clouds, and altostratus can be differentiated from nimbostratus with two different aspects. One is the height, because nimbostratus started from very lower in a positions, so it can started from, for example, half kilometer above from the ground. On the other hand, altostratus started after 2 kilometers to 6 kilometers, it can be extended. And then nimbostratus also, we cannot expect any sunshine in here, but in the altostratus we can see some watery sun in the sky. So these are the differences between nimbostratus and the altostratus. And nimbostratus, from nimbostratus we do expect rainfall, but not very vigorous way. So it can give you a long time rainfall, from maybe from whole day or for whole night. It can give us the rainfall, but not too much, not too much rainfall. Yes, it can give you too much rainfall if the nimbostratus rainfall, when it has been producing rainfall in that time, if there are some cumulonimbus clouds that is also producing from other sides or from a near distance place, so that time it can also give us more rainfall. Another type of clouds is stratocumulus. Stratocumulus cloud is looking like you can stratocumulus. You can see this is a cumulus type of clouds, chunk of the different patches of clouds, which is dark and white and two different colors. Here is white, here is dark in color, and you can see little bit about the bluish sky also in here. So stratocumulus cloud is actually a light to dark, and it doesn't actually give much of the rainfall, but maybe it can also rarely give us little bit of rainfall. And we can also sometimes see the sunshine in between these gaps. And stratocumulus cloud can also be very much confusing with the altrocumulus clouds. But altrocumulus cloud and stratocumulus cloud can easily be distinguished with your hands, as I said in the last class, that if it is a stratocumulus cloud, you can take your hand and it could be around your fist, like the structure. and that is the length and the width of the stratocumulus cloud. On the other hand, if it is altrocumulus cloud, then it could be length of your thumbnail and thumb, and you can see also the width is very lower, because as the altrocumulus cloud is far away, so it should be very little, and stratocumulus, it is very near, so it can be easily distinguished between that two. Another type of cloud is stratus cloud, which actually give us no rainfall, but looking like a relatively a liftment of the watery vapor. And this cloud is very much common by the side of the Atlantic and Pacific Ocean, and that can also be sometimes confused with nimbostratus cloud. This cloud can be confused with that one, but we can also, again, it can be also differentiated, because observing the low base of the stratus cloud, in the stratus cloud is very much lower in the positions, and that cannot give us any type of rainfall. So, and there is no layer in here. There are layers, but no distinguished layer. But in the nimbostratus cloud, we can see turned up or rack shaped clouds, and here you can see foggy shaped cloud. Sometimes we can also say the fog, if it is uplifted little bit due to the vaporization, then we can also expect stratus type of clouds. So differences of stratus and nimbostratus will be very sharp if you can minutely see the structure. Now, today we are going to discuss more about the cumulus type of clouds. So cumulus type of clouds means which is piled up. So one after another, that can be producing a huge piled up. And under the cumulus cloud also, we can say that it can be of different shape, and it can also producing different types of form. And then we can also distinguish it in only the, if you see only cumulus type of clouds. So this cumulus type of clouds can be started with from 1 kilometer above from the ground, and that is also very different than the stratocumulus, because in the stratocumulus we can see the blue sky little bit, but in the only cumulus, if it is only cumulus, then you can see a very great part of the sky very nicely. Although it is compacted, but you can very easily see other part of your sky. So it is very visible in nature. And if it is very not so big, and it's tower shaped, and then if it is also seen that some vertical growth is not too much, then we can say this is cumulus humilis, humilis. On the other hand, if it is the segregated, not segregated form, it compacted form, then cumulus clouds, that is we call cumulus congested. So between that two clouds, cumulus humilis, that doesn't actually give you any rainfall. We cannot expect too much rainfall from this type of clouds, because you can see also that we can see the bluish sky, and it moves very forward, moves forward with the movement of the wind. On the other hand, this is also cumulus humilis. You can see a lot of sky in between two chunks or three chunks. But, and also you see these are tower shaped clouds. These are tower shaped cloud. You can see these are tower. This is tower. There is no horizontal base in here. And cumulus congested is also looking like tower, but you can see the patches are very compacted. So this type of clouds also generally don't give you the sky much of the rainfall. So sometimes in the sky we see a huge amount of the cloud, and maybe one side of the sky is fully covered with clouds, dark clouds, and we expect much of the rainfall, and maybe after a couple of minutes or couple of hours, the sky again is very clear to us. So that is cumulus congestus. And cumulus congestus can give us rainfall if this cumulus congestus develop further. That means if it grows up with another type of clouds, that is called cumulonimbus, we are going to describe now. So if it is formed further, then we can only expect the rainfall from here. Although this is very compacted in a form, but it is the height of this cloud is not too much. And as it is not too much heighted in a form, so it started from 1 kilometer, say up to 2 kilometers. So the temperature in tropical region, for example, in Bangladesh and many other such like countries, we don't expect rainfall from here, because the temperature is still not in a freezing condition. even not in a condensed form. So how the cloud can be again in a condensed come to liquid form, and then if there is no liquid form, then how it can be precipitate. So that's why from cumulus congestus we don't actually expect rainfall, but this is a starting of the development of the cumulus clouds, cumulonimbus clouds, and then further development can give us much of the rainfall. So this is a cumulus congestus. And between this cloud, cumulus congestus and cumulus humilis, there is a two differences. Here, although this is not horizontal form, but the sharpness is very fine, and there is distinct nature between two of them. On the other hand, cumulus congestus, they are very compact in nature, and they are cauli-shaped flower design. You can see these are looking like a cauliflower, each of them looking like cauliflower. And when it's further developed, then this design or this structure will be changed, such like in a cumulonimbus cloud. And the last one, but most important one, is cumulonimbus cloud, which can be started from the 6 meter above the from the ground, 600 meter from the ground, and it can extend it last long from 12 kilometer. So 12 kilometer means it can extend it very high enough, and it can be all the way to high level clouds. So this is cumulonimbus clouds, which started very lower in the positions, but you can see it started from. What is the characteristics of this one? First characteristics is the huge amount of the piled up positions. Second characteristics, the convective energy is too much in here, and the draft, convective draft, that means the lower to upper and upper to downward, both the way the movement is very vigorant, so that the vapor can easily be going to top, and then again in other positions it can easily to come down. So that's why it is very important. See this one. And another thing is very important, that the top of the cumulonimbus cloud, which is very much horizontal in nature, and there is no tower shape. So this is cumulonimbus clouds special characteristics, that the top of them is very much not very much sharp. It is very much gentle in nature, such like this one, very gentle in nature and horizontal in nature. And another character is we called it, this type of top we call anvil, ANVIL, anvil top. So this is a structure which is only related with cumulonimbus clouds. You see all the other clouds, they don't have this type of specific, not horizontal position in the top. You see these, all of them are different shape, but only the cumulonimbus cloud can give us this type of. And now the important thing is, as it is going from the top to bottom all the way along, so some of the parts of it is accompanied with water, some of the parts which is accompanied with the ice crystals. So when it comes to top to down, when it go to the top, then it can be condensed, and then it wanted to come. Now the question is, maybe you can also ask, why the cumulonimbus cloud don't give us ice crystals every time? Actually, when it is coming from the top to down, as it is almost 12 kilometers, so most of the time when it is wanted to come, most of the tropical region, or in our cases, they don't give us much of the other form of the rainfall. So when it is come, it takes again the energy from the atmosphere, and it again crystal form to they turn to liquid form, and then finally we get in the down, we get liquid form, because in the tropical region almost of the couple of kilometers they have to come with a heavy high energy, and that high energy, when it wanted to fall up, then they take again the energy and they change their behavior from ice crystals to liquid form. So this is the nature of the cumulonimbus clouds. Another important thing is, cumulonimbus cloud is accompanied with thunder, lightning, and also even tornadoes sometimes. So it is very important, because of the high convective nature, they can give us different sets of environmental phenomena. Why it is the only one? Why not the other clouds? Because you see the differences between other clouds and cumulonimbus clouds. It started from one region, last long from other region. So all the way along, they have different characteristics. And scientists also don't know why it is happening, but they know how it has been happening, the lightning. because lightning can be possible where one reason is lightning happening because of the differences of the electron, positive and negative charge. So scientists expected that in the top of them and down of them, in the downward they are much more negatively charged, in the upper level they have positive charge, and all the way along it is very compacted, so the electron passes is possible very easily. And with the heavy shower, this lightning also possible to come up from the cloud to the ground. So that's why lightning is accompanied with cumulonimbus type of clouds. But keep in mind that these height and these nature also be different in different regions of the world, because the temperature of, for example, in 2 meter, this is 2 kilometer, so up to 2 kilometer the temperature of tropical region, which might be like 15 degrees centigrade, or maybe 20 degrees centigrade. On the other hand, if you go to the Europe or North America, maybe the up to 2 kilometer, the temperature will be -5 degrees centigrade, or -10 degrees centigrade somewhere. So in that positions also, even it is 2 kilometer, but in some of the cases it is turned to ice crystals. On the other hand, if it is in the tropical regions, we don't expect this is ice crystals. We expect this is still watery in form. Even in the mid-level also watery form. When it goes to up near to the higher level, then only can we expect this is ice crystals. And all the way to the downward, when it wanted to come back, then again they change their shape, again they take the energy. So this is the nature of the cumulonimbus clouds. And then we're gonna say that from all these clouds type, we can expect much of the rainfall from most of the cases cumulonimbus clouds, and then some continuous rainfall from the nimbostratus clouds. But this nimbostratus cloud don't give us much of the shower. It gives up to slight to moderate rainfall, and we also expect no hail or snow from the nimbostratus. Normally we do expect in tropical region, we do expect the not snow, but because snow form has other type of conditions, snow forming conditions. But in case of the tropical regions, sometimes we also expect hail, or maybe some of the such like structures, which is accompanied with cumulonimbus clouds. On the other hand, altostratus and altocumulus in the mid-level, they can sometimes, maybe altocumulus cloud give little bit of the rainfall, and also maybe sometimes drizzle can be also possible. If the cloud is very much compacted in the sky, but don't give you any type of shower, it could be a stratus or it could be nimbostratus. On the other hand, if you find little bit drizzle, it can also be possible from the nimbostratus. And if it is cumulus type of clouds, they don't give you much of the shower, so they can be developed and move very fast. But from the cumulus congestus, maybe the cumulonimbus cloud can be formed. And from the high level clouds, even though they can also be coming as a very ice crystals form, and they can wanted to come back, but normally we don't expect much of the rainfall from there, because this smaller amount of the rainfall, when they are very much saturated and they wanted to come back to down, but all the way along when they wanted to come back, they again get the energy, and that will not be a good shower for the ground. So that's why type of clouds is cumulonimbus and nimbostratus. Someone asked me that, sir, what is the anvil top in the picture? Yes, thank you very much. Anvil means it is a veil-like structure. That means the cover up, the top, and this top is very much horizontal, no tom shape. No, there is no dome shape or tom shape, you can say, or no sharpness in here. Okay, so this is anvil top, and this is all only accompanied with cumulonimbus cloud. So the horizontal form that can only be possible, that is called anvil shape. And this is also started from in a higher altitudes. If it is in the lower altitudes, you can say there are different type of shapes you can expect. But here, almost it is horizontal. Almost it is smooth in nature, and it is made up of ice crystals. This is anvil top. Is it okay? Okay, thank you. And then we are going to discuss about precipitation classification. But if you have any question regarding the cloud classification, you can ask me. Do you have any question, anyone, regarding cloud classification? Can you hear me? Hello, all of you.
Sir,
Can you hear me?
can you tell about the three main characteristics of cumulonimbus, sir? Sir, you told.
Yes, yes. Cumulonimbus or nimbus stratus? Which one?
Sir, cumulonimbus, sir.
Cumulonimbus is first characteristics is it started from very downward. That means maybe from the 1 kilometer it started, and it will last long up to 12 kilometers. This is the first characteristics. No other clouds can be formed in um, such a height. This is a piled up clouds. That means cloud after cloud, and this is not a layer shaped. This is piled up shape. Secondly, we can expect high amount of the convective matters, which is not possible in other type of clouds. So convective matters means it gets huge amount of the energy. They can release it and they can get it during the condensation and during the vaporization. Yes, Shubhra asked me, can lightning happen only? Yes, yes, only lightning can be possible in cumulonimbus cloud. Yes. And then another characteristics is its anvil top. That means horizontal in nature. So even cumulus congestus, you can also sometimes be confused with this one and that one, cumulus congestus and cumulonimbus. Then you can see this is a tower shape. This is, you can see some conical shape, but here it is not conical shape. It is very straight. And from cumulonimbus clouds we can expect some of the as it is in a very top high shape. So in the higher altitude we can expect ice crystals. In the lower form we can expect liquid water droplets. It is also very special. Do you want to know, is it clear to you, everyone?
Yes, sir.
If you have any other question. Yes, Nazmul Hassan Rumi, please. Najmul, you can ask me. Nazmul Shahriyar. You raised your hand, Nazmul. Do you want to tell something, Nazmul?
No, sir.
Okay, then you should not raise your hand. You raised your hand, that's why. Okay. Anyway, so this is our cloud classification. Yes, there is another question. Mursalin, can tell some difference between cirrostratus and altostratus. Obviously, you see, this is cirrostratus and this is altostratus. Cirrostratus give you a hollow shaped. Hollow, what is hollow means? Hollow means by the side of the sun you can expect a very dark in color, which is round in shape or spherical shape. On the other hand, altostratus don't give you a hollow shape. They give you a shape which is the sun is floating. That means you can say watery sun. You see sun dimly visible, but there is no hollow in here. You see, this is not a very good shape. This is very much sporadic in nature. So cirrostratus and altostratus have two basic things. One is hollow, another is not hollow. On the other hand, in the cirrostratus, it is very high cloud, and here altostratus in the down cloud. And cirrostratus usually cannot. Sorry, Mursaleen, can you just muted it? Okay, thank you. So so in the cirrostratus, it is a high level cloud. That means it started from 6 kilometers above, and normally we can't see this type of clouds. But altostratus cloud, as it is lower in positions and much more widespread, That's why sometimes it can be distinguished very easily than that one. There is no hollow in here. The only the watery sun can be expected. So if you can just measure your height, you can expect in the mid-level two type of clouds, altostratus and altrocumulus. But altrocumulus have different shape, and it can be distinguished easily because they are piled up in a nature and they segregated from one another. But on the other hand, altostratus, they are not segregated, but they are dimly visible. That means the sun is dimly visible in here, and then you can only expect to see the altostratus. Is it clear to you?
Yes, sir.
Okay. So now we are going to move further to understand precipitation. Precipitation, sometimes many people think that precipitation means rainfall. Yes, you can say rainfall is one type of precipitation, but precipitation means any type of watery substances which is coming from the atmosphere to the downward and finally fall to the ground. They are precipitation. So depending on the different nature and formation process, precipitation can be different types. It can be rain, it can be snow, sleet, or hail, or it can be different. So depending on the form, we can expect two different types. One is very watery and another is ice crystals. But before we going to describe the precipitation process, we need to discuss a little bit about the measurement process. Sorry, not measurement process. We need to little bit to know about the units of the precipitation, because how can we measure it? What amount of the rainfall has been occurred during last couple of hours or maybe last one day. So we do expect that precipitation can be, most of the cases we do measure it in millimeter. So normally we say 5 millimeter, 10 millimeter, or 20 millimeter rainfall. What does it mean? So what does it, because millimeter is the height, how can we say the height? Think about a 1 square meter square area. 1 meter square means 1 meter width and 1 meter length. So that if you can just enclose the area and then you pour water, 1 kg of water in there, then that will give you a little bit of the height. That height means 1 millimeter for rainfall. So if we have any instrument and like 1 meter square, if you know that this is 1 kilometer square, 1 meter square, and then if the height is 1 kg water in there, we can measure it 1 kg, and then the height we know what amount, that is our 1 millimeter, correspond to 1 millimeters. And how we can measure it, the measuring process we're going to discuss maybe in the last class of this cloud chapter. And precipitation have a very strong relationship with the ground temperature. As I said before, if the ground temperature is actually very high, then you don't expect much of the ice crystals in a very lower altitudes. It might not be possible. Another thing is important is time and space, because in the rainy season, in the summer season, we do expect much more temperature in the ground, and depending on that, if you go to the higher altitudes, then your temperature also has a relation with that ground temperature. For example, in case of Bangladesh, now it is 35 degrees centigrade, for example, on an average. On the other hand, in the winter, in some of the area, in that sometimes it could be 15 to 20 degrees sometimes. So if it is 20 degree and 35, there is a huge gap. So that gap can be covered by maybe two kilometer. Two and 2.5 kilometer. That means in each of the kilometer, we do expect 6.5 degree temperature has been losing up if we go to the higher altitudes. So depending on the season, the cloud formation will also be different. Depending on the space also, as I said before, tropical region and the higher altitudes, they have much more differences because of this temperature altitudes. So when I show this one, so these numbers, that is also fully dependent on the locations. So this book is perhaps from North America. So according to their visions, they wrote it. But maybe in our cases, it could be a little bit higher because their temperature and our temperature has a very big differences. So that's why it is also dependent on the time of the space. But one thing is sure that clouds start to come to a precipitation formation when, that means it will come to downward when the relative humidity is approaching to 100%. That means near to 100%. And relative humidity means is what amount of the water vapor that can be present in the atmosphere and what amount is present now. The ratio between that two is our relative humidity. So sometimes maybe it is very important for snow formation also, because sometimes the saturation is not in there. In that case, in a higher temperature, even maybe a 5 to 10 degree centigrade also we can expect sometimes, if it is lower temperature in here. So sometimes it can be also expected some snow falling or snowflakes. Now, before we starting, just to quick understanding, precipitation can be two types broadly. One is liquid form, one other is in a crystal form. That means ice crystals. So if it is in a liquid form, then you can expect rain, drizzle, mist, different types of liquid droplets or gopal. On the other hand, snow can be snow form. That means crystals form can include snow, slate, hail, and different other types of formation. So liquid precipitation we are gonna discuss now. So today we are starting from rainfall. We say rain because the drop of the liquid water which fall to the ground, if it starts from 0.2 diameter, 0.2 millimeter, sorry, 0.2 millimeter of diameter, then we can say greater than that we can say, sorry, not 0.2, 0.5, sorry, 0.5 to 5 millimeter or 6 millimeter, we can say this is raindrops. And if it is lower than that, we don't say, if it is lower than 0.5 millimeter, we don't say this is rainfall. We say this is that is drizzle or mist. So rainfall has a specific sharp ranges about their diameter. And rainfall when fall from top to down, the terminal velocity, that means when it is near to ground, it is almost 2 meters to 10 meters, depending on the nature. And when the rainfall can be found very normally, the showers from cumuliform clouds are usually very brief and sporadic in nature, but the cloud moves over it and then drifts by one. And if the shower is excessively heavy, then we say this is a cloud burst. Okay, we say the cloud has been bursted out. That means huge amount of the shower is producing from that type of clouds. So it's a cloud burst. And then continuous rainfall can be expected from from layered cloud. That means from nimbostratus, for example. So nimbostratus give you a continuous rainfall, but not in a heavy shower. That means not too much all the way. Nimbostratus can give only that type of shower if the combination can also take place from some cumulonimbus type of clouds with the nimbostratus clouds. And now maybe it is important to know that what is the structure of the raindrop. So if you see the first one, type 1, so most of the cases in our different drawings, we expect a rainfall shaped like this. This is a cone shaped. But actually rainfall is not looking like this, because this is only you can see in a drawing, or you can see this is in a cartoon, like this conical shaped. Yes, uh, conical shape only can be possible when it is falling from a structure. That means I have a drop of water on my hand, top of the hand, and that drop of water wanted to fall, not fall, wanted to fall. That time maybe the surface tension can make it like this type of a structure. But if the rainfall is like less than 2 millimeter in a positions, or such, like if it is a very small in shape, then most of the cases this is a spherical shape. That means a rounded shape. Okay. On the other hand, if it is a bigger, that means near to 5 millimeter, then its shape is like this. The lower portion is very horizontal and gentle in nature, and the top of the portion, this is a rounded shape. So This is the structure of a rainfall normally. And if the rainfall rain is less than, the diameter is less than 0.5 meter, that means 0.2 to 0.55, then we can say this is a drizzle. And drizzle can be expected from low stratus cloud. As I said before, the stratus clouds has been grown up from a foggy condition, and normally we do expect some of the little bit rainfall, not too much. And sometimes the drizzle can also be formed if the rainfall is coming from a little bit higher altitudes, and then they again take some energy from the atmosphere, and they again vaporize in a condition. So some of the rainfall, maybe they don't fully vaporize, part of them are vaporized, and the rest of them coming up. That time that also called drizzle. But if it is hanging on the atmosphere, it is not coming down to the ground, that means it was rainfall, but when it wanted to come back, then it has been evaporated again, and some parts remaining in the air with a so minute structure, with a lower lower humidity, then we called it is a varga, virga, varga. So varga is a type of precipitation that is hanging on the streaks of the precipitation that is hanging on the atmosphere, and that is not a fully raindrops, but relatively very minute type of drizzle in possibly floating in the air. And drizzle causes poor visibility, obviously, and this can also be accompanied with fog. So this means drizzle. Maybe we can start snow in the next class, how it has been formed and how it will be. So if there is any other question, you can just raise your voice now. You can ask me any type of question you have. Do you have any question? Okay. So if you don't have any question, may I ask Siam to provide me the absent roll number later?
Yes, sir.
Okay. And hopefully we'll come back again in the next class on Monday. Yeah.
Okay, sir.
Let's see. I'll give you the schedule in Google Classroom, and I do also recommend you to go through the books of Ahrens, which I gave you a PDF format, and sometimes
Yes,
I also write down the page numbers also in here. I don't know, you just quickly just see that things, and you can just note down that things, so that you can easily get the description which I am going to describe here. So you can get the full description in there, and you can understand it or not. If you just go to a very quick go through of each after each of the class, for example, today, if you just read all these parts, even you read couple of pages, then it will be very easy for you to understand and take your notes. Okay.
yes, sir.
Okay, so thank you joining me, and hopefully we'll come back in the next week in maybe. Thank you all.
Assalamu alaikum, sir.
Walaikum assalam.
Assalamu alaikum.